Hello guys, welcome to our class. For today we are going to be looking at radioactivity. Don't forget that we have started our classes on atomic physics. So we have discussed the concept of the atoms and the models of the atom. So in this particular class we are going to be looking at radioactivity. So guys, please get your writing materials ready and then be in a quiet place so that you can follow through and avoid distractions. Alright, so this is Nobleman Science Tutors Online, and I'm Tubo Michael. I'm your online physics tutor. So if you have not subscribed to our channel, please subscribe to the channel. Click on the notification bell so that when we upload a new video, YouTube will notify you. Alright, so please give us a like, give us a thumbs up if you like what we are doing, and then invite your friends to come and enjoy what you are enjoying. Alright, so if you have your writing materials ready and you are ready for the class, we'll be going straight to the class. And in this class we'll be looking at the nucleus. We'll look at the nucleus, we'll look at radioactivity, as I've said. Then we'll also look at radioactive decay, radioactive particles, and properties of radioactive particles. So these are the areas we are going to cover in this particular class. So hoping that you are ready, please let's go straight to our class. Thank you. So as I've said, we are looking at radioactivity. When you mention radioactivity, most of the reactions that has to do with radioactivity, they take place in the nucleus of an atom, right? So we still need to look at the nucleus of the atom again. Okay, we need to look at the nucleus of the atom again. What are the components of the nucleus and isotopes and all that? So we have discussed this before in our introduction to the concept of atoms. So this is more or less like another revision part of that same topic. So the nucleus of the atom actually consists of the proton and the neutron, while the electron surrounds the nucleus in an orbit. We have discussed this before. So the neutron and the proton constitute or form the core of the nucleus of the atom. Alright, and the mass of the atom is concentrated in the nucleus. Yes, the mass of the atom is concentrated in the nucleus. Why do we say so? The mass of the atom is the sum of the proton, or the number of protons, and the number of neutrons in an atom. So the mass of the atom is concentrated in the nucleus. The neutron, as I've said before, has no charge, while the proton has a positive charge. Okay, and because the proton has a positive charge, that is why the nucleus of an atom has a positive charge. Now, the proton number Z is the total number of protons present in the nucleus of an atom, while the mass number is the total number of protons and neutrons present in the nucleus of an atom. That is what I've discussed before. Now, the nuclides of an atom refers to an atom with a specific number of proton and nucleon, specified proton and nucleon number represented by this. Nucleon number is the mass number of an atom. Okay, so an atom can be represented by this sign. The Z stands for the atomic number or proton number, while the A stands for the mass number or nucleon number. Right, then isotopes are elements with the same atomic number but different mass number or nucleon number. Okay, so these are examples of isotopes. This isotope of carbon, this carbon 12, and then this carbon 14. Then we have oxygen 16 and oxygen 17. Each of these one have the same carbon 12 and carbon 14 have the same proton number but different mass number. Oxygen 16 and 17 have the same proton number but different mass number. Okay, so this is about the nucleus of the atom. So now we are going to look at radioactivity. So, what is radioactivity? Radioactivity is the spontaneous decay or disintegration or breaking down, so decay, disintegration or breaking down of the nucleus of an atom, of the atom of an element, and during which process radioactive particles are emitted. So you have emission of alpha particle, you have emission of beta particles, and you have emission of gamma rays, or a combination of any or all of the three as the case may be. And accompanying that emission, you have energy. So energy is also emitted when these reactions take place. Okay, so radioactivity is a spontaneous decay or disintegration of the nucleus of the atom of an element, during which different radioactive particles are emitted. So alpha, beta, gamma particles plus energy are released. So elements that disintegrate spontaneously and emit radiation, they are known as radioactive elements. So radioactive elements are those elements that spontaneously emit radiation from their nucleus. Example of such elements, we have radium, we have thorium, we have cobalt. There are many. We have uranium is there, we have radiance and all that. Okay, so we have them many. So experiments have shown that when these particles are released from a radioactive source, they are deflected differently when placed in either a magnetic field or an electric field. So when a radioactive particle is emitting radiations of the different particles, they are deflected differently in a magnetic or an electric field. So we have the alpha particles, as we have said. The alpha particles are, when they are passed through magnetic or electric fields, the alpha particles are deflected towards the negative plate of an electric field and towards the south pole of a magnetic field. And because negative charges attract positive charge, the alpha particles are positively charged. Then beta particles, they are deflected towards the negative plate of an electric field and then the north pole of a magnetic field. And these ones, they carry negative charge. The gamma rays are not deflected, whether in a magnetic field or an electric field, they are not deflected, and as such they carry no charge. All right, so these are some of the behaviors of radioactive particles when they are placed in either electric field or magnetic field. Okay, so these are areas that you need to take note of, because these are typical examination questions that you may come across. So I hope that is clear. All right, so we're moving on. So this is what we just discussed. In a magnetic field, this is the behavior of the different particles. Okay, so alpha particles will be deflected towards the south pole, while beta particles towards the north pole, and then the gamma rays, they are not deflected at all. Okay, so this is a photographic screen where you can see the particles as they are being emitted from this lead container. This is a lead container, and this is a compound that is being this is a radioactive compound, either uranium or thorium. Okay, now when they are in an electric field, they still have their difference. Beta particles are deflected towards the negative plates, while alpha particles are towards the positive plates, while the alpha particles are deflected towards the negative plate. The gamma rays, they are not deflected. Okay, so this behavior of these particles that are released from a radioactive substance is very important that you take note of them, because these are typical examination questions. Okay, gamma ray will move straight, alpha particle will be deflected towards the south pole, and gamma to the and beta to the north pole. Then in an electric field, beta particles to the negative plate, beta particles to the positive plate, alpha particles to the negative plates, and gamma particles, they will not be deflected. So please take note of this and have a memory of it, right? Okay, so we'll also look at different types of decay, right? Because when you talk about radioactivity and we said the decay of a radioactive substance, we also look at the different types of decay. So we have alpha decay, we have beta decay, and then we have gamma decay. Or you see you have alpha disintegration, gamma disintegration, and beta disintegration, as the case may be. So radioactive decay is a process where the nuclei of a radioactive element undergoes a series of disintegration to become stable. So it is not affected by external factors like pressure, temperature, chemical treatment. No. So during decay process, the total mass number before and after decay must remain constant. Okay, so this is typically for any chemical equation. So when you write a chemical equation, definitely the masses on the left or before the reaction, they are equal to that on the right after the reaction. Okay, so that is what happens. For for alpha decay, the parent element will lose a helium atom. It will lose a helium atom, so which means that the parent elements, the mass number will decrease by 4 and the atomic number will decrease by 2. So this is a typical example of what I just said now. Okay, so X is the parent atom with atomic number A, mass number, atomic number Z, and mass number A. So the mass number will decrease by 4 and the atomic number by 2. So, and that gives you a helium atom. This is a helium atom, right? With mass number 4 and atomic number 2 plus energy that is released. An example is radium. So radium will decay to radon by losing a helium atom plus energy. This helium atom is a positive alpha particle. Okay, so this is a typical example of an alpha decay. So you need to take note of this, and you need to take note of this and have it in your memory, because you can be asked in an examination that which of these equations represent an alpha decay. Alpha decay will lead to the release of a helium atom. Okay, and this is the helium atom. So any equation where you have a helium atom being released is an alpha decay. So please take note of that. Okay, just take note of that, and then you have your answers correctly in your examinations. So let's look at another decay, beta decay. Okay, so just like in alpha decay, in beta decay, the atomic number of the new element, the atomic number will increase by 1, while the mass number remains the same in beta decay, because what the element is releasing is an electron. So beta decay leads to the release of an electron. Alpha decay will lead to the release of what? A helium atom. Okay, so beta decay leads to the release of an electron, while alpha decay leads to the release of a helium atom. So for a beta decay, the parent element we have an increase in atomic number, but the mass number will remain the same for the new element that we form. Okay, so in this particular case, X will release an electron, to yield Y with the same atomic number as X, but different, with the same mass number as X, but different atomic number with the release of energy. So this is a typical beta decay, and the beta particle is an electron. Alright, so please take note of this. So example is the decay of thorium. So thorium will decay by emitting a beta particle to produce a protactinium. So if you look at this thorium and protactinium, they have the same mass number but different atomic number. You see that the atomic number has increased by 1 unit. Okay, the atomic number has increased by 1 unit. So this is an example of a beta decay. Then the last type of decay is gamma decay. In this gamma decay, there is no new compound that is formed, but only energy is emitted. So the mass number and the atomic number remains the same. Nothing has changed. So this is an example of a gamma decay. So please, you have to take note of these various decays that take place in a radioactive element. And one thing you need to take note of, when you are balancing a nuclear reaction equation, you must ensure that the sum of the atomic number Z must be equal on both sides of the equation. Also, the sum of the mass number E must be equal on two sides of the equation. So if you look at this equation, you find out that here this is 234. This 234 plus 0 is 234. This is 90. Okay, so 90 plus 1 is equals to 91. Okay, so this is 91 and this is 90. So minus 1 plus 91 is equals to 90. Okay, so what is on the right side is equals to what is on the left side. I hope this is clear and this makes sense. Okay, so we now look at, we have looked at different types of decay. So we'll look at the properties of radioactive particles. So what I've done is I try to put them on the table so for your easy understanding. So if you look at this, see radiation, nature of radiation. So for alpha particle, this is beta particle and this is gamma particles. So the nature of alpha particle, they are helium atom, while beta particles, they are high energy electron, and then gamma rays, they are waves or electromagnetic wave or short wavelengths. Okay, that's the nature of each of these particles. Velocity of alpha particle is 5 to 7% of speed of light, and beta particles at the speed of light, gamma particles at the speed of light. Charge, alpha particle, they are positively charged, beta particle are negatively charged, and gamma ray, they are what? Neutral electrically. Mass, alpha particle, they are large, beta particle are relatively large, while the mass of gamma rays, they are negligible. Effect of magnetic field, alpha particle are deflected to the south, beta particle to the north, and gamma ray no effect. Effect of electric field, alpha particle deflected to the negative plate, beta particle to the positive plate, and gamma particle no effect. Ionization power, alpha particle high ionization, beta low ionization, and then gamma ray no ionization. Penetrating power, alpha particle, they have small penetrating power and they can penetrate through thin sheet of paper, all right, through thin sheet of paper, while beta particle, they penetrate through several millimeters of aluminium. So then gamma rays, they have higher penetration, they can penetrate through many centimeters of lead. So these are some ways that you can differentiate between alpha, beta, and gamma particles. So if they say differentiate between gamma, beta, and alpha particle, this is where you can just pick some of these informations from this table, and then your answer is readily available and ready. Okay, so please, what you need to know is basically try and know the difference between each of the particles, especially their charges, the effect of magnetic field, effect of electric field, ionization power, and penetrating power. Okay, so that when you are asked in an examination, you should be able to give at least three differences, at most five differences. All right, so gamma rays have the highest ionization power and penetration power, but no ionization power. Alpha particle have the highest ionization power, but very low penetrating power. So you should try to know these differences, and then you'll be good to go, right? So please, this is where we are ending this particular class. I hope you have had a nice time, and we are happy that you have been with us thus far. Okay, guys, so I think this is where I'm ending this class for today, and thank you so much for your time, right? So please, if you have not subscribed to our channel, what are you waiting for? Subscribe to this channel, give us a like, give a positive comment, and encourage us. Invite your friends. Okay, reach us to the WhatsApp number that is showing on your screen. I remain Otobo Michael. We appreciate you. We appreciate for your time. Thank you for being with us so far, and we promise to continue to bring out the best materials for you. Okay, and for those who are preparing for their WAEC examination, which is coming up very soon, we wish you the best. We hope that our material will help you to be your best in physics. Okay, so thank you so much, and we hope to see you in our next class. Thanks, and God bless you.